Hi friends, today we will discuss a topic related to science and technology, that is related to space technology. So before going to this discussion, some points it has to be clarified that what are the questions which is coming in the science and tech and how should be your approach. If you go through the trends, the science and technologies questions which are coming, they are a current affairs based question. But to do the current affairs based question, it has to be keep in mind you have to know the concepts. You have to know the concept related to general science. All the general science concepts are related to it. So as I will be discussing an space and technology topic where there is also some basic general science concepts of physics are there. So I am representing you a slide, and with this slide I will discuss the topics. Now here in this first slide, what you are getting, you are noting that I have given a figure of the orbits. There are the different orbits I have shown here. Now, and I have given a chart. So what are the charts are there in there? The type of orbit, the distance from the earth, orbital period, and type of satellite. Now the thing is that why we are reading this thing? The basic thing is that we want to explore the space. As it is known to us, a space is a thing which is nearly invisible to us. Now the concept of invisible means, so we want to say that 5% we can observe and the remaining 95% is invisible. That is, so there should be exploration which will depict what this 95% is it, that you have to find what this 95% is. And if we go in little bit of depth, we will find to know this 95% is composed of two things, that is dark energy and another is dark matter. So dark energy, it is like it is expanding, and dark matter which is contracting. This is the theories there. So now these orbits which I have shown you, you will be knowing that in this orbit what we do, we set a satellite with the help of a launch vehicle. So a launch vehicle takes a satellite, and after this the satellite are put into different orbit for different observations. Now this is the figure of an earth. We know that now in this earth, first the orbit which is given, that name is LEO. Now if we go in depth, means what is the full form of LEO? This is known as low earth orbit. So that means here we define low earth orbit with the help of the distance, that means this altitude. So when you take the altitude, the distance from earth, from the surface of the earth, you can take it is 200 to 2000 kilometers, and its orbital period is 1.5. So what is the orbital period? That means the satellite is moving with which velocity? That velocity is 1.5. And what type of satellites we are using, and that satellite, it is given, it is known as remote sensing. So the low earth orbit having the altitude length of 200 to 2000 kilometer, orbital period of 1.5, and the satellite is remote sensing. So remote sensing is that type of satellite which can be held to get the informations regarding any weather predictions it can give. It can give you an observational satellite thinking. Next, the orbit which is there, which is a MEO, medium earth orbit. So this picture which I have given to you or in the slide will be much more give you the clarity. Now in the medium earth orbit, the range is the factor from the 2000 to 35,786 kilometer. This is the medium earth orbit. Now here the orbital period is increasing. So the one thing is coming to our mind that if when we are increasing the kilometer, the orbital period is increasing. This medium earth orbit is used, means the satellite which are used is for the navigation purpose. Next, number third is geostationary orbit. Now this geostationary orbit is that orbit which is more than or above the 35786 kilometer. So geostationary means when you take the range of 35,786, it is known as geostationary orbit, which has an orbital speed of 24. So when we are increasing the length or the kilometer or the distance, we are getting that orbital period is also getting increased or enhanced. This GSO, it is also used for communications purpose. And HAO is the high Earth orbit, which is more than 35,786, has an orbital period of more than 24, and it is also used in communications. So these are the types of orbit, and as I told, the third orbit which I told, geostationary orbit, for that you have to keep in the mind this is also known as a transfer orbit. So the things is that when a satellite goes with the help of a launch vehicle, it first makes its footprint in the transfer orbit. So from the transfer orbit, it is shifted to another orbit, that may be geostationary orbit. So geostationary orbit, before that, the transfer orbit, the satellite gets seated. Why is the reason? Because transfer orbit is that place, if we put the satellite from there, so we will have a much more probability that where we will fix that our launch vehicle or the satellite where we will put. So now this geostationary and another is geosynchronous. So geostationary is that its position is that like that, it is in the equator position. It is at a fixed point, we can tell. And geosynchronous is that which has an inclination, somewhat tilted. Now this orbit, if you have an idea, then you can quickly have a look that we have all some missions take place. Now the current missions which will be in the line, we have heard about the Aditya L1's mission. Now this Aditya L1 mission, we know that this mission will be for observing the sun's chromosphere, that is, or the sun's corona. Now this spacecraft Aditya L1 will be put in a Lagrange point which is L1, and it will be directly focusing on the sun. Now where it will place this spacecraft? It will be placed in the HEO, high Earth orbit. So if you don't have that understanding, see what is a high Earth orbit? So when you placing a spacecraft in a high Earth orbit, you can have a much more viewer angle. That means you can have the look of the sun's chromosphere or the coronal region from where the coronal mass ejection take place. And this coronal mass ejection is an important factor not only for auroras happening, we have heard this term, auroras australis, auroras borealis, and also the solar storm or the geomagnetic storm which take place or which happens. So you have to know the source. Where is the source of the storm and how this from the source. That means we can tell from the source there is the particles are there. Now these particles, how it affects the magnetic field of the earth. For that, what will happen? Your communications can get damaged, we know that. So these findings has to be done. So we have heard this mission, but you have to know the orbits. So this is the first of all the basic concepts of the orbit. So if we go a little bit that why a satellite does not fall from an orbit. So this is a basic general science. As I told, you have to clarify on the basic science concept. The satellite, why does not it falls? Because what it happened, the satellite's orbital velocity, what we can tell, it's equal to the pull. That means we know that this orbits, in the orbit the satellites are revolving. Now the satellites, they had getting a pull a gravity pull is there, which gravity pull is counterbalanced with the centripetal pull. So when both this pull are equal, this satellite in the orbit remains. Now, when we go to our next slide, here the orbit is much more that we are telling about your polar orbit. That picture I have also been shown, and in this picture, as you know, the how much altitude it will be and how it will be moving from north and south. So you can have the understanding that this polar orbit will give you the overall informations about what informations it will give about the formations of any forest fire which is occurring. That informations can be given in this polar orbit where a satellite is placed, and that satellite is at low altitude. So we can tell this position as a circular position. Now, when we see sun synchronous orbit, this is also a LEO, low Earth orbit. So low Earth orbit, polar orbit, sun synchronous orbit, both are the same, means both can be known as a low Earth orbit. And if you go to the range, you will be finding that it is shooted at which range for the low Earth orbit is there. Now the point is that now in this sun synchronous orbit, what is happening is that there is a particular position, or it is synchronized. That means a fixed position is there in correspondence to the sun. That means the satellite will be visiting the same point over and on. So if suppose it is placed at a region, at a place, suppose at Paris. So after that, in the same time, suppose 12 o'clock. So every day at 12 o'clock, its position will be fixed at that point. So the thing is that it will give. So now I am putting that satellite for a span of 1 month. Now for this 1 month, I will observe that place. Now when I am observing that place, I can have a concrete decision. So these are the findings I have got. These are the findings which I have got from it after a prolonged observation from time. So to get a prolonged observation or the findings, what you have to do? You have to place that satellite in that sun synchronous orbit to get that views. Now, this is the types of another orbit. This is I have also tell you. Now I given a diagram and thing to understand the transfer orbit and geostationary transfer orbit. So transfer orbit, that means which is used to get from one orbit to another. So you are transferring that. So you have taken a launch vehicle, any launch vehicle come and it sit on that particular orbit, and after that you change that orbit. So this means this geostationary. So when we talking about this geostationary orbit, so it is generally, we can tell it is more or less elliptical in view. So earlier the low Earth orbit, it was more or less, we are telling it is a circular view. Now this one is having a point of a elliptical view. This is a ellipse which we are getting this viewpoint. Now after this, this is the points. These are the Lagrange points. Now when we going to this Lagrange point, you have to keep in the mind that these are the imaginary points. Now these imaginary points of 5 things are there: L1, L2, L3, L4, L5. We are seeing that. Now in this picture, it is very much easily be seen that this is the sun position is there, as you noticed. Now there this L1 point is there. So before that I have told you that in L1, Aditya L1, that spacecraft will be positioned here. So this point L1 which will be positioned. So you can see from if this L1 is here, and if you position this spacecraft at the L1 position, you will be finding that it is viewing the sun's chromosphere predominantly. Now this is the, what is this is the Earth, the planet, and this is the moon which is revolving right the Earth, and this another point here is the L2. So these L1, these L2 and L3, these are the unstable point. That means in this point there is no stability is there. Now at the L4 and L5, this point are what we are getting. These are much more stable. Now the reason why this is the unstable. Why? See, now the unstable is there because we know there is a gravitational pull is there, and another is a tangential pull. So gravitational pull, that means suppose which we can tell the sun which is pulling the earth, we can tell with the help of the gravity. Now the earth is also getting pulled tangentially by somebody here. Suppose this is the pull, we can tell as I am showing you. So this is the tangential pull which is a perpendicular, and this is a gravitational pull which is doing by the sun. So when these two pulls are there may be a instability may occur. So these points are not equilibrium. The basic concept of there. Now the thing is that when somebody is pulling it, as I told you the concept earlier, that there is a dark matter and dark energy. So what is that dark energy? Which is expanding. That means within the time span we are finding that we are expanding the Big Bang. The thing is that increasing, and the dark matter is that which is contracting. It is contracting means something is pulling. So the thing is that when we will have that the concept of gravitational lensing, you have heard that thing, that we know the light travel in a straight line, but here we can find in the space light has a curvature. Anything in the space there is a curvature. Now the curvature can be proved, that means with the help of the gravitational lensing. So if you throw a light on any object, that means that object it will be getting reflected. So when it getting reflected, its line will not be a straight, it will getting little bit of bend. This is a very basic concepts of the physics are there. This is the science and tech. What we know, that means not only getting the reading the current affairs will not work. You have to know the basic concepts which are working, the theories of Einstein. Basically, not going in detail, we are not required that. So L2 is that point, as I told, this point where the James Webb Telescope is there. So if you don't know the point, then we can think this James Webb Telescope, which is a much more modern version or updated version or infrared telescope of the Hubble's, which was earlier by the Hubble's or Herschel telescopes are there. And but within the Hubble or the Herschel, this one is much more what we can tell advanced, and we are getting that this L2 telescope will move also toward the sun orbit. Earlier Hubble, it was orbiting in the earth orbit. Now when it is orbiting to the sun, that means a much more clarity, we can get the thinking of the galaxies much better. So the L2 point is that point where the James Webb Telescope is there. So James Webb Telescope, little bit of thinking of the current affairs, I also giving you the idea. James Webb Telescope having a big mirror is there, we know, and it will have also be given the thing about the star formation of the galaxy. Till now we have known about the toddler stage. What is the toddler stage of the galaxy's formation is known to us. So before a toddler stage, there is we can tell an infancy or infant stage, that is from the starting from 0 to 1.5 months or 1.5 years of a baby. That like that stage we have is that of the life formation, that can be easily be known with the help of this James Webb Telescope, which is a infrared version, and it will be giving you much more coverage of the micron, that is 0.28 or 0.6. So small object can be equally be visible with this help of this James Webb Telescope. This is also the current affairs point which I have discussed, which will be placed in this L2 point. Now think about this. This is also the L2 point which is described here also, and I have also given you the idea that this L2 point and where this James Webb Telescope is there, it will have a much more vision, much more clarity of the happenings of the galaxies, the star formation, the nebula, how the nebula has been formed, the neutron star, everything's given a good coverage or good picture. A picturization is good. As I am giving you a picture of this Lagrange point of the orbits, which is will be a much more imprint on your brain. Only giving a lecture will not work. That's also like that. Now, when we go through this L2 point, and this is the L1 point. So L1 point, I have told you also that where this Aditya L1 missions will be there. Sun, Earth L1, making the observation of the Sun and Earth. And this Aditya mission is there, which will give you all the clarity about the things are there, solar winds or the coronal mass ejections, everything will be given. Now the thing is that astronomical missions. Now in this part, what are the things we have to know that when a missions when we take, there are the three objectives we have to keep in the mind. So any astronomical missions which we took place, like any Aditya missions, or if you take the place of this James Webb Telescope, or the Mars mission, or the Chandrayaan mission, which will happen, the lunar missions will happen. So here are the three things which comes. One, the part is the first is the orbit, in which orbit it will be going, that which clarity we have got, whether it will be the low Earth orbit, whether it will be the geostationary orbit, or whether it will be the high Earth orbit. The Aditya mission is the high Earth orbit is there. This is the thing is that. Now the wavelength is that. Wavelength is a factor, is how much, in which region will be that. Which region? The wavelength is how much wavelength. Wavelength is a factor. That means we have a term thing is that if the energy is this, that means any ray whose energy is less, that means its wavelength is much more. So this is a factor. So this is the factor which is related to an astronomical mission. And the launch vehicle means, we know the launch vehicle with which a spacecraft is going. That may be a GSLV or that may be a PSLV. And also other small launch vehicle which are also coming. That is small satellite launch vehicle or nano satellite launch vehicle. These are also coming in the pipeline. So astronomical missions are related to these three parts. Now these types of launch vehicle, when we are reading that, now I have given you the picture, PSLV, GSLV, these are the variant 2, 3. And before this PSLV, you can also have the ASLV, Augmented Satellite Launch Vehicle, which is in the earlier. Now this launch vehicle stages, velocity, weight and orbit. Now the thing is that we have given the stages. So there are stages means, before you will be getting that, in each of these three stages, the solid is at the first stage. Now the point is that, why the solid is at the first stage? It is a basic science concept is that, if there is a solid propellant, if we can work, it will have a much more a thrust or much more energy. So if you give a much more thrust, that will, what will have, it will help to the launch this vehicle more easily. That's why it's a basic thing why we are not using the liquid first and then solid. So generally what the thing is that, what are the stages are there, the fourth or third way are starting with the solid and then we go into the liquid and then again solid and liquid, like that. Now the first thing is that if it is a PSLV, means Polar Satellite Launch Vehicle, this launch vehicle, it will be working in which orbit? It is in the low Earth orbit, that is 200 to 2000 kilometer, which we have read earlier. In that orbit we are using this PSLV. Now this PSLV is that it's having the weight 1750 and 1425. That means when it is going to the sun synchronous polar orbit, its weight is 1750 it can. So sun synchronous means like this orbit. That means that orbit which is in a circular position. Now when it is geostationary orbit, that means which is in a elliptical orbit. So we can tell a launch vehicle can go in sun synchronous also, and also in a circular mode, and also in a elliptical orbit. That is should be clarity is there. So don't get confused whether it is PSLV or GSLV, we can carry it on any orbit, but the difference is that the weight capacity is there. So you will be finding that if you go through in a low Earth orbit or sun synchronous polar orbit, this orbit are its low altitude is there. Yes, so low altitude means, that means we can take much more payload. So there are payload is there. Now you were asking what is the payload? Payload means when you are having any astronomical missions, in there are some payload like any cameras, like any cameras will be there, or any type of satellites which we carry for this mission, we can take as a payload. Now this payload also is used in the defense also, because when you work any missile, that missile also work with a payload. So there, in that case, that payload can be a conventional payload or also nuclear payload. So nuclear means when we can take any nuclear fuel with that, or any bomb, nuclear bomb, we can tell it's a nuclear payload. Now in this PSLV, the GSLV, Mk2 and Mk3, the three stages are there. So the solid stage are that we uses that solid propellant. Now solid propellant is generally what is that? We use that hydroxy terminated polybutadiene. We take HTPB. It's used as a solid fuel. And in the liquid fuel, we generally take the hydrazine. Hydrazine is taken as a liquid fuel, or we can tell as a kerosene. This kerosene is also now using in where? In RSLV. Information giving, reusable RSLV, reusable launch vehicle, which India has till now completed this two stage. That is, one is the takeoff and another is the landing stage. This two has been completed, and the two stages are remaining in where? In the RSLV, reusable launch vehicle. Means what? Launch vehicle we take or we make a mission, and that launch vehicle, what happened? It makes, when the fuel is not there or like that happen, that launch vehicle, what will happen? It makes a debris. So now reusable is such a thing is that which can use this launch vehicle again. So these are the four stages there. One is the takeoff and one is the landing. These two stages we have succeeded. Now the after that, which is the deorbiting stage, and another is that the scramjet propulsion is that stage is still two stages are remaining for us. So then this reusable launch vehicle we can also take as this. These are the kerosene as a fuel. And there is another C. See the stages given here. The C means cryogenic. Cryogenic, what is that? It is a science of low temperature. It is very much utilized in industries, we can tell all in the magnetic train or the magnet train. That technology of super magnet or super magnetic coil, we use this cryogenic thing. So this cryogenic is such a temperature or cryogenic fuel which India has taken place after when there was when there is a need, when the Russians who want to help us, they have given only the cryogenic engines but not the technology. That was in the past 1991, in that era was there. So from that we have modernized our techniques, our technology, and we have generated this cryogenic. So only 5 countries are there. So these cryogenic fuels are required for this GSLV launch. So the GSLV also gone in the orbit of LEO and GTO. So this GSLV, when I am taking that the part, we can tell this GSLV will be the recent launch for our Gaganyaan mission. That means humans will also be going in the low Earth orbit where they will be staying for the 7 days. So this launch vehicle will take that. So GSLV is the thing is that what we get confused, that GSLV means only in geostationary, not. It can be also used in a low Earth orbit and also can be in a geostationary orbit. And this is the variant. So when we take about the variant, basic understanding of variant, to know that how to differentiate a variant is different from the earlier variant according to its weight capacity. So weight capacity will deal that. SSLV, this is also another topic which I have told, that is small satellite launch vehicle, and it is very important or current topic. Recently we had what we can tell, we have failed in this mission, because what will happen, there is a one type of technical glitch in the velocity tree module. It should have been this small satellite launch vehicle should go in a circular orbit, but it's opted change and make it in a elliptical. So this was the problem were there, and there was the 3-stage propulsion. So there is 3 solid stages also there. So there may be also some stages where we can also get only the solid, not the liquid or any cryogenic. Next, this are about the remote sensing. So remote sensing satellites, what we have told that remote sensing which given you the about the observations, what we observe different and how we observe this with the different bands. So there are different bands, L band, S band, R band. So in this different bands of wavelength is there when the light falls, and when it get refract, then we can observe what is the position is that, what is the picture is that can be clearly known. Indian remote sensing satellite, which is used the synthetic aperture. This synthetic aperture radar, this is what with the microwave, and I can think that SAR, this radar is like that in a very clear concept. If you have a ship, now a ship is a very large, or a vessel, if you can tell, if a large vessel is there. Now with this synthetic aperture radar, or we can tell NISAR and ISRO, means US and India are collaborating, that a long patrol vessel can be easily be looked or find each and equal positions. So that means at different length we can have the observations of the vessels. That's why where we use that microwave. This is the basic funda of this NISAR and SAR. So the thing is that there are different remote sensing satellites, which also that ES-01. This remote sensing satellite, these are generally for the fact of the observations. Carosat, OceanSat, different. One for the ocean study, one for the marine study. For that different regions, these are being used. This is also GSAT. This is also another which is remaining in the geosynchronous orbit. In these different orbits, we are monitoring or navigating the things. This is about the NISAR, which I have told you. This is the navigation system of different world, which we have our own is the NAVIC, and you will ISNS. That means India's navigations, IRNS. It is a helpful of there are 7 satellites are there, 3 in geostationary and 4 in geosynchronous. Total we have 7 satellites which is in this IRNSS mission. 2 are in a standby. So this satellite are positioned in such a way that will give you all type of internal coverage of the related to our security purpose. These are the lunar missions. As we know, in the lunar mission, generally we have to keep in the mind about the Chandrayaan. So Chandrayaan 1 was there. In the Chandrayaan 1, there was only the orbiter was there. In Chandrayaan 2 and 3, there is the lander case is there. That means lander and rover. So in Chandrayaan 2, we know that the lander crashed, the soft landing not take place. So Chandrayaan 2, where it has stopped, now the Chandrayaan 3 is coming in the point. And the main thing is that in the Chandrayaan 3, we have to look for the what observation about the south pole of the moon, because south pole is moon is for because there are much crater are there, and there is water availabilities also is there. So when the crater water is there, so we can have the idea that in this crater the fuel can be there. That fuel can be utilized for a spacecraft. So spacecraft can be refueled. We know that by the docking system of that we can refuel the spacecraft. So the lunar missions or the moon missions is very important. Same as that Artemis is also in the pipeline, where the US is also be sending some men and women. So these missions are that we have came to know overall idea of the basic of the science and technology. What are the orbits? What are the different orbits are there? What are the launch vehicles, their fuels? And we have also learned different small mission, SSLV. The current affairs is also related. Hope you have liked this video. Thank you very much.